Welcome to this tutorial about how to use an Arduino as an ADSR. The source code is in the link below. I've posted everything on GitHub. And so today we'll just explain what it does and then how to use it. So when I started with ADSRs, I looked into linear and exponential ones, but really a linear ADSR wasn't any use to me. I mean, after all, your ear is not linear, so it just sounds really artificial, especially at volume on the release. It seems like the sound just stops out of nowhere. Whereas with the more exponential differential curve, it's more natural. It eases out and then goes to zero. So I evaluated quite a few different forms, and I very much like the differential implementation that MOXPD has made. Also, that is linked below. And so that's the one that I took and then further optimized, because the one thing about the MOXPD implementation is that it's really best effort. So it just cycles through and then every time updates this differential equation. So it's very hard to make an absolute timing to it. There's no reference to a time signal. And that's why in my implementation, I redid this and then referenced to the micros function within Arduino. So now it's really to the microsecond accurate ADSR, where you can say, I want that tech to be 100 milliseconds, and it's no more, no less. So that gives you great flexibility when designing your synthesizers with a very precise AD and R. All right, so this differential equation that's implemented is shown over here. So the next sample, in+1, is partly 1 minus alpha, the target value where you want to go, and then plus alpha times the previous value. And then, of course, when you change alpha, you get a different shape. So the alpha can be somewhere between 0.992 and 0.997. In my implementation, I use a lookup table. And so at the generation of the class, the curve is made and then it's mapped in during operation. That makes it just extremely fast and easy to operate. All right, so let's have a look at how to download it, how to install it, and how to use it. Here's the link, but I'll also have that in the description below. To the GitHub, and you just go to code here and then download zip. Then it'll download here below, so we'll show the folder. And you'll have to unzip it. In some way or the other, I couldn't get GitHub to skip this main thing in the folder. So we're going to go rename and skip main and just call it ADSR, because that's what the folder should be called. So we're going to copy this thing, and you're going to go to your documents, then Arduino, and you'll find here a libraries dictionary. So you go in the libraries dictionary and then paste ADSR into this libraries dictionary. So that's basically it. Library is ready to be used, but it kind of helps to also see an example how you now use it within the Arduino program. So that's why we're under examples. You can find ADSR example. So let's copy that as well. And you'll just go to your Arduino library and throw it in there. All right, let me open it up. Opens, of course, on my other monitor. Oh no, here you go. ADSR example, here we go. So it's pretty straightforward. We have some variables in the beginning: ADSR attack, ADSR decay, sustain and release. That's basically where you set the ADSR shape. And of course, in your program, you want to be able to vary those. So you might link it to a potentiometer or to MIDI controls or anything like that. Then you have certain trigger duration. Here in this simple program, we're going to just periodically trigger the ADSR so that we can see the shape. And then there's a space between the trigger as well so that you can see the release. Then there's some internal variables. Don't worry about that. That's just to be able to trigger on and off. If you're going to actually use the ADSR class on your own, you probably not need those. So the class is imported over here. It will automatically go into this libraries dictionary. So as long as you called that folder ADSR, it will be able to find it. And then the class is initiated over here. So it says ADSR, make a new instance. And I just called it here ADSR class. But if you need multiple ones, you can just go ADSR 1, 2, 3, 4, 5, etc. Okay, so and then in the setup, I use here an Arduino Duo just for simplicity. It has already a DAC built in, so it makes it really simple to use. That's why I have here analog write resolution 12. That is a specific command that with the Arduino Duo, you can use all 4096 levels for the DAC. And as well here on the top, the DAC size is of course set to those 12 bits. All right, and then let's go into the loop. And the loop is pretty straightforward. We always start with taking a timestamp, and we call this T. Then we're going to update the waveform and just throw it out to the DAC. This lower portion, so here, by the way, ADSR class, get wave, that kind of updates the waveform based on timestamp T. And so it will be scaled to the DAC size because we already provided the DAC size to the class. And then here, this is just a simple trigger where we either switch on or we switch off the trigger. And that's basically it. So let's have a see here. I just compile and throw it onto the Arduino Duo. Of course, you need to have set here at tools the board to Arduino Duo in this case, or you need to just kick out the Duo specific stuff and write to another Arduino. You need to, of course, set the right COM port. Okay. And that's about it. So it now updated and is up and running. And here on the scope, we now see the result. So we see here an attack, the decay, sustain, and the release. And let me briefly go to the scope. So I'm not sure if you can see this on the screen. But you'll see that this attack here is exactly 100 milliseconds, and that's also what we put in. Also, if I scroll over, then you'll see that the decay as well is 100 milliseconds. And then finally, the release on the right is also 100 milliseconds. So this is how you now have a very time-accurate differential ADSR that also has a very light load on your Arduino as it's implemented with a lookup table. Have fun with it. Let me know what you think of it, and see you in the next video.